This is the lower part of a side-loaded zigzag vintage sewing machine. Now you will see how the mechanics move when sewing. What you see here is that the shuttle housing here is moved left and right with a movement of the needle above. I made this modification with a spring here and an attachment with some steel thread here, and it pulls in the shuttle also with some steel thread coming around it here. This pulling of the shuttle reduces the slack, so it pulls the slack in the mechanics to one side. I did this modification because I wanted to sew something like this. It is a stretch material, and I will try to explain why I recommend this modification for a side-loaded machine in the coming minutes. This is my Singer 237 vintage sewing machine. It's a side-loaded zigzag sewing machine produced between 1968 and 1972 in Italy. Side-loaded means that the thread is loaded from the side in the needle eye. Most other zigzag sewing machines have the thread loaded from the front. Some of the first zigzag machines had side-loaded kind. For instance, the Italian Necchi machines was like that. Many of the Japanese sewing machines made in the 50s and the 60s was also side-loaded machines. I had a problem when I tried to sew with this machine on some stretch fabric like this. Then I started to get skipped stitches. And it is a common problem with this kind of stretch material to have this problem. I shall try to explain some of the basics of sewing machine, and you got the needle coming through the fabric like this, and then it is pulled back again, and you see there is a loop that is formed. This loop is to be catched by the hook like this. So and then a stitch is formed. However, with stretch fabric you have a phenomena called flagging. The reason for the flagging problem is that fabric is elastic, and therefore when the needle is pulled back, also the thread is pulled back, and it causes this loop to be much smaller, and then it is harder for the hook to catch it. It can be like this, and then it becomes critical what distance the hook got to the needle. With a large loop it is not that critical with the clearance between the hook and the needle, but with this flagging problem the hook needs to be just nearby the needle to be able to catch this smaller loop. When this machine was designed, knit stretch fabric was seldom. Therefore, the designers was not aware of this. But later on, much more garment things are made of stretch fabric today. Now I'll try to tip the machine over. This position of the needle and this shuttle housing here needs to be synchronized exactly. This becomes the main problem. This is an axle from above, so the movement of this zigzag is synchronized with the needle. But there is a lot of mechanics here and over here. In the end you will have some slack here. This slack in the mechanics means that the distance between the needle and the hook becomes uncertain. I made a pull here in the shuttle of 1.2 kilos to one side and 1.2 kilos to the other side, and try to measure how much movement was on the shuttle housing. I could see there was a slack in the mechanics here of 0.4 millimeters. It's actually quite a lot, because you will normally have 0.1 or 0.2 millimeters between the needle and the hook. If you make an adjustment here that is too small in distance, then you have a risk that the needle and the hook actually can collide. That's not good, because then the needle can break and other bad things can happen. Front-loaded sewing machines do not have all that mechanics here. So therefore they have an advantage with clearance between the needle and the hook, because the shuttle housing here will be fixed in relation to the needle. Now I will tell you a little about a modification I made to the machine in order to cope with this. And I got this steel thread here I have used for many things. It's a 1.5 millimeter diameter thread, and I have bought it in some building supply shop. So I can recommend you buy something like that. Then I had some spring from somewhere else, and I put this steel thread here over here and through some holes that was there already. And then I have this little part too, and then I am able to pull there in the shuttle. You still have some possibility of slack of the mechanics for moving the needle above. But there's a lot more mechanics here to position the shuttle here. So therefore, major part of the slack can be reduced with this arrangement. This spring pulls about a half kilo or 5 Newton in the shuttle here. I got a smaller spring here, and I could have used that. That would have pulled about 0.2 kilograms or 2 Newton. I think this is about the level you want. It can be a little hard to position and adjust this clearance. You do it on a screw on the top of this axle, but there is no possibility to make a fine adjustment. You actually have to have a little friction left there when you move it, and then you try to measure here with and then you know how much you have moved, and then you try once more, and so it is kind of trial and error to get the right distance between the needle and the hook. The good thing about side-loaded zigzag machines is that it is not so sensitive when the fabric is moved a little forward or backwards, and in this way the needle could be bended a little forward and backwards. If you do that on a front-loaded machine, bend the needle a bit to the back, the hook can catch the needle. This sensitivity is less on this kind of machine. This modification helped significantly with my effort to sew zigzag on this stretch fabric without breaking any needles and having problems with this kind of machines for this. So I recommend to make this modification if you got a side-loading machine and you want to sew stretch materials.